Okay, this question is question 1. So we are showing an isosceles triangle that's inscribed in a circle, alright, with a fixed radius r. So I want to show that the area of the triangle is given by a equals to half r squared 2 sine theta plus sine 2 theta. Now this question may bother quite a lot of students, but the trick to doing this is actually to break down the triangle into 3 parts. Okay, so let's take a look. If we were to just split the triangle, okay, for example, into 3 portions, let me just cut it into half, the theta into half. Okay, I'm going to look at them as 3 different triangles. Okay. I mean, for easy naming purposes, let me maybe call this Q, P, and R. If you don't want to do that, it's fine. The main thing is you are able to identify the triangles correctly. Okay. So if you look at this, right, because this is theta, right, and we are bisecting this into 2, so this angle here, I can say that it is theta over 2. Similarly on this side, this is also theta over 2. Okay. Now, knowing that these 3 angles add up to pi, which is 180, this would be pi minus theta. Okay. Now this is pi minus theta. Now on this side, alright, is also the same. Now because what you know that this both of them, right, for this triangle here, let's say triangle OPQ. Let me put the center as O, right? Okay, so triangle OPQ, right, you can see that it's actually an isosceles triangle as well because both sides are the radius. Okay, both sides are the radius. So then from here, this portion here, this will also be theta over 2. Right, this will also be theta over 2. Right, again, because OPR, triangle OPR is also an isosceles triangle. Given that this 2 is theta over 2, this angle here will also be pi minus theta, right? Because we are looking at a triangle which is isosceles. Now, taking the difference of taking pi subtract theta over 2, your remaining angle here is pi minus theta. Now, as we look to the left, here below, which is triangle OQR, right? We know that sum of angles here is equals to 360 or 2 pi. Now, taking away pi minus theta, if you just calculate this angle here, should be equals to 2 theta, right? Because if you take 2 pi subtract 2 of pi minus theta, what you just get is 2 theta. With this triangle here, OQR, you can also see that it is an isosceles triangle. Okay, and these 2 angles should be the same. So with that, more or less we have what we need, and from here, right, we are going to calculate the area of the triangle one by one. So first, if you look at OQP, right, this is just half AB sine C, area of triangle, half AB. In this case, the A and B are just the radius, sine C. Now there are 2 of it because this triangle here and this triangle here are of the same. So I'm going to multiply it by 2. This triangle here, half AB sine C, half AB sine C. Okay, so that is the area of the green section here. As I calculate this eventually, taking 2.5, that gives me 1 r squared of sine pi minus theta plus half r squared sine 2 theta, sorry. And we all know that if you use the supplementary angle formula, sine of pi minus theta is also equals to sine theta, which allows us to write down this as r squared sine theta instead, since these 2 are the same by the supplementary angle formula. And with that, we are almost at the end point already, right? This is great. A equals to half r squared, 2 sine theta, okay, plus half r squared sine 2 theta. If I pull out half r squared, inside I'll have a 2 sine theta plus sine 2 theta. Yay! And we are done with part 1. So part 2 is really not too difficult, because part 2 is just to calculate and do the differentiation, which we all love, right? So we want to find the maximum value of A So that means that we need to do, again, we need A as a function in terms of one variable. And here it's very obvious that this is the A here. Okay, so it makes sense if you want to do dA dr, or okay, so let's do, maybe we do dA dr equals to 0. Right, so we need the function to, we need A, step 1 now, we need A in terms of probably, okay, it might be easier to do theta because that I see 2 theta, there's only 1 r. So perhaps what I'm going to do, I need A in terms of theta. Okay, now here, one of the things to consider is that if you look at the r is also fixed, right? So we can't do dA dr, unfortunately. So that is also my oversight. R is fixed. Okay, so if they say that r is fixed, right, that means the r is a constant. We cannot differentiate with respect to r. Okay, so do take note. This is very important. This might be the part where most of you may be stuck. Okay, now dA d theta here, I'm just going to differentiate. I'm going to keep half r squared outside. Take note that this is a constant. This is a constant. This is fixed. The moment they use the word fixed, it's trying to tell you that r is a constant that you don't have to worry about when you are differentiating. It is not a variable. Differentiating 2 sine theta, that gives us 2 cosine theta. Differentiating sine 2 theta, that gives us 2 cosine 2 theta. Okay, equal. And that's step 1. Now step 2, of course, since we are trying to find the maximum, right? We're trying to find the maximum. It means that we need to do dA d theta to be equals to 0. Right? Again, if you look at my previous videos, you know that I always draw a graph, and I will have A theta A, that this particular value of theta here, that gives you the maximum A, right? dA d theta. So with that, dA theta equals to 0. So I'm going to equate this entire expression here, half r squared 2 cosine theta plus 2 cos 2 theta equals to 0. I'm just going to cancel away half r squared, right? Let's divide by half r squared on both sides. Okay, this is dividing by half r squared, which is a constant. It doesn't bother me. So 2 cos theta plus 2 cos 2 theta equals to 0. This looks pretty daunting, right? But this is just a very humble trigo equation that you solved in the past. Change this, 2 cos theta. I'm going to change this using the double formula. This is 2 of 2 cos squared theta minus 1. Right? So I'm trying to get the trigo variable to be cosine theta. I'm going to try to get the same trigo variable so that, you know, in a sense, when I'm solving this, it is like I'm solving a quadratic equation where cosine theta is the variable. Right? So that's why, if you notice how I approach this question, if you remember your JH3 stuff, is we change this to a single, okay, all to the same trigo variable, right, which is to get it cosine theta, cosine theta. So 2 cosine theta, 2 and 2, that gives me 4 cosine square minus 1, that gives me minus 2. So you notice that the approach to solving this equation is just like solving 2x plus 4x squared minus 2. It's really no big deal, right? Personally, it's a good habit to simplify the equation. If you notice that all of them are multiples of 2, how about you just, you know, divide all by 2, and you have cos theta plus 2 cos square theta minus 1. Okay, rewrite this as 2 cos square theta plus cos theta minus 1, right, in decreasing order. Then it is easier for you to factorize now. 2 cos theta minus 1, cos theta plus 1 equals to 0. Okay, this is just solving as though you're solving 2x squared plus x minus 1. Now from here, if you're equating to 0, I think whatever that follows should be much more digestible. So this is 2 cosine theta minus 1 equals to 0, which means cosine theta equals to half. Or over here, cosine theta equals to negative 1, which unfortunately you will not have a solution because theta has to be less than pi. Okay, because you remember that your theta here is inside a triangle. Okay, so therefore there's no solution for this. If you have cosine theta equals to half, let's inverse this, find the basic angle, theta is just equals to pi over 3. Okay, so it tells you that in this section here, if you want to find the maximum value of A, you need to have theta equals to pi over 3, which remains that, of course, we need to check first. So step 3, right? Step 3, after we found theta, number 3, step 3, always you need to check or verify or check the nature of a stationary point. Okay, why do I say verify? It's because I mean you sort of, there's only one there in this case, right? So to be strict, if you don't use verify, you should also say check. Okay, check the nature of the stationary point. Let's find the second derivative. It looks easier to differentiate the second time round. So this is the second derivative. Okay, the second derivative, oh sorry, just a slight dash there. Second derivative would be d2a d theta square. I'll just leave you to work it out. I'm just going to write down the answer. Okay, and after which, remember how we do the check is with the second derivative, we substitute theta inside, all right, and we actually find the numerical value of the second derivative. You do need to find, you can't just write down less than 0, that's all. You can't do that. You need to actually find and do the substituted value. So if you sub theta equals to pi over 3, you need to actually calculate and do the substitution at theta equals to pi over 3. Your d2a d theta square is equals to negative 2 sine pi over 3 plus 4 sine pi over 3 times 2 is 2 pi over 3. Okay, now calculating this, your final answer will just simplify to negative 3 square root 3 over 2 r square, which is actually less than 0. All right, the form is not specific. If you were to do it in non-exact form, that is fine as well. Okay, so from here we verify that yes, that means theta equals to pi over 3 gives a maximum value of the area of the triangle. Okay, so after that, have we answered the question? Now some questions they will stop at here, they will just ask you what's the theta, but in this case, if you look at the question, they ask you what's the maximum area. So it means that you need to do your due diligence to substitute the theta back into the area expression, right, to find the actual maximum area. So at theta equals to pi over 3, remember our area formula just now was half, it was this, right? Our area formula is half r square 2 sine theta, so this is 2 sine theta, which is pi over 3, plus sine 2 theta, which is sine 2 theta. Okay, now do the substitution. Remember to keep it in gradient mode, and the final answer would be 3 square root 3 over 4 r squared. Take note that r is a fixed value. Okay, so it's not an actual value. Okay, so that will be the final answer to this question. Thank you.